welcome again to my workshop. Today we're going to be talking about welding. Now this video is being produced in conjunction with the build of the large MAXI CNC router. So in your home workshop there is about 3 cost-effective ways of welding. And the first one, and probably the cheapest one, is what is known as a stick welder. But now we come to MIG welding, which is my preferred means of welding. I find it a lot easier. However, it is quite a bit more expensive. This little MIG welder is, not the bottom run of the ladder. It is probably now these days about somewhere between $700 and $900 worth. But the old saying, you get what you pay for. There's a lot more in this to go, not go wrong exactly, but there's a lot more in it. Basically, there's a big transformer inside here, the same as the stick welder, except you have a big fat cable. Inside here there's an electric part of the cable on the outer side. Then running up the inside is it's something like a brake cable off a off a motorbike or a push bike. In other words, this wire is fed up the inside of this, and it comes out here at the nozzle. Well, actually, when you press this trigger and you have a gas bottle connected to it, I'll just get the regulator, because at the moment I don't have a gas bottle on this. This is a regulator for the MIG gas. Now that's a mixture of CO2 and nitrogen. But in Australia, where I'm from, it's for home use it's very expensive to have. It turns out that the small bottles this size is $300. You have to put $200 deposit on it and then pay $100 for the fill. So to cut down costs, and actually this is the pure MIG wire. This is steel wire coated with copper. It's coated with copper. Stop it rusting. So that's that one. Now this is a large reel length, relatively large for this machine, of what is known as flux core welding wire. So in other words, with the stick welders you have the steel on the inside and the flux on the outside. Well, with flux core, steel is on the outside like a tube, and the inside is filled with the flux. The flux is there to stop the interaction of oxygen in the weld. Okay. So and this is what we're going to be using today. In fact, went out and bought a handyman version of this. This is about I think this is about $20, something like that. So I thought I've never used one of these small ones before. I've always used the larger size, but I thought I'd give it a crack, as probably this is what you'd be using, and see how we would get on with it. Now, in this particular case, it's called Gasless MIG wire, alright, for general purpose mild steel again. And so I'll show you how to put one of these into the MIG unit, the big MIG welder, and how it operates and what to do with it. So inside here, this is where the drum roll fits here, so you just simply take off the spring behind it and that. So I've threaded the wire through to the outside because you need the wire to come up over the back here to feed into here. There's a motor inside here, something like a windscreen wiper motor that is variable. There's a switch on the front that you can vary the speed at which it feeds the wire up the cable there. So we're going to put this on here like so, backed up by this. A spring, then just put a bit of tension on that. Just make sure it can turn, but you don't need to have it turning too freely, otherwise, like I say, this will unspool on you. So we'll switch it on. Now holding the wire, I got the hold of the wire on the underside of the wheel here so it doesn't unwind on me. Hopefully, oh, I got a bit of a kink there. You can't have any kinks at all. You'll just get, see the kink there? It'll get jammed up the cable. So we'll cut that bit off. Get rid of that. Just feed it into this entry here. Straighten a bit. Feed it into the entry here. Okay, we got it in the entrance there now to this tube. Lock that in there and just load it up a little bit. So I've got it started. Now I'm going to pull the camera out of it a little bit so to give you a better view of what I'm doing. So what you need to do is have this out straight, fairly straight anyway. And then pull the trigger and it will feed it up. If you feel this kinked over, it's possible to get it caught up. Okay, so you can actually see that it's come out here now. So this is the shield, actually, the gas shield, and the center bit is, I suppose you could call it the electrode, because it is that center copper like jet sort of thing, but the metal is fed through. That's what transfers the electrical current into that wire. So let's see if we can get a bit of a weld going now. Okay, gasless MIG welding. Now this is why I love welding with this. It's a complete different animal. It's so much easier and it gives such a better weld that you know, if you can afford it, this is the way I would suggest you go. Now I've got this set on a don't know whether you can see it, it's on a medium setting, medium power output. It's about 80 amps approximately, because this is a 140 amp welder as well. So it's between 80 and 90 amps, about 65% feed rate. Okay, so that's the speed that the wire actually comes out. Look, every machine is, I suppose, different, and you know, you would need to try it yourself. Do a few test runs. I'm going to show you a test run now. I've done a couple just now, and this is set the same as when I last used it, which was probably about 3 years ago, and it's perfect. So I hope the other camera that I've got here behind this welding shield is picking this up okay. I haven't viewed it yet, but it's the best I can do, so hopefully it's going to come out. It might be a little blurry. So here we go. I'll show you how to do a run with, and you'll see yourself how much easier it is. So now you can see the difference. And now there's a run with a stick welder, and now there's a run, perfect run, with a gasless MIG welder. So you can get a prettier weld, and I would say a stronger weld, and it is much easier to use. You don't have to feed the stick in as well as bring it along. You just keep it at a constant distance away from the material, about half an inch, which is 13 millimeters, and you know, you sort of get the wire feed the correct amount, and the ampage set in correct, and you can do a perfect weld just like that. In actual fact, now I've got these two pieces here, I may as well weld them together. of course the welding process is very, very much quicker. Little bit of splatter, as you will always get splatter. You can minimize that. You can get a spray that minimizes this. In actual fact, I found about 35 years ago, I found a little trick that if you spray this with spray fat, okay, it eliminates all this, and this will just brush off, and it doesn't affect the weld at all. So there you go. Gasless or flux core MIG welding. It's relatively simple to do, and you get a pretty damn good result. This over here somewhere, and take my apron off. So that's two totally different, really, methods of welding. There's nothing really hard about it. It's just knowing or having some idea of what to do and practice. You know, you just don't go buying something like this and hooking it up and getting your two bits of metal and putting it together like chewing gum. Probably wouldn't be a very good weld. You've got to practice. On pieces of material like this, you know, go down the hardware store, buy a couple of lengths of this, cut it up. You can either cut it with an angle grinder, or I've got a motorized rotary hacksaw. I've also got a steel cutting drop saw over there. So, you know, I'm kitted out to do it. But a small angle grinder with a cutting disc, you know, you can cut this stuff quite successfully, and you know, get practicing. Now, depending on your budget and what you think you like, I would point you in the direction of a MIG welder with a gasless flux core wire. But you know, you can still get a successful weld with a stick. You know, there's nothing wrong with using a stick. It's just that you know, as I get older, I find the easier that I can make a job, easier all round it is for me. You know. And of course, the better equipment you have, the better weld you get. So, if you would like me to do some more videos on welding and that sort of thing, even brazing maybe, please leave a message in the comment section. And bear in mind, I'm showing you how to do this, or how I do this, how I've learnt how to do it. through requests of in the comment section and by patrons to be able to prepare them to make the next big router build, which is of course the MAXI CNC router that I'm in the middle of designing. I actually started designing it about 3 months ago. I had to have some idea of what size it was going to be, so I could order the ball screws and the linear square rails, which I've got. I did an unboxing, I think, it might have been the last video. So I'm going to be preparing to make the chassis to put all that on, and it's going to be welded box section steel. Anyway, that'll be for another video. This is a welding video. I hope you've liked it. Hope it's been a help to you. If it has, please press like and subscribe to my channel. And if you would like to become a patron, and incidentally, all the drawings, parts and specifications of all the builds I do are available on my Patron pages, as indeed the CNC milling machine conversion from the X2, the 7x14 CNC lathe, also, I've got a list of them now, the MIDI CNC router, which is a 40x40 or 400x400. Nice little size that one is actually. I've done quite a number of videos on that, making it, and what it'll do, carving and engraving in brass and what have you. And also now the start of this larger, more industrial size CNC router that I hope you're going to enjoy. And if you are interested, obviously you need to become a patron to get all the parts information, what I paid from them, what I paid for them, where I got them, the suppliers, and how much. And I'm trying to do this whole build, okay, for less than 2,500. I'm going to come in close, but with fluctuation of prices, it could be closer to 3,000, but I shouldn't go over that at all. And thank you for joining me, and well, until next time, bye for now.